So here we have the 2017, this is question 3A, Leaving Cert Ordinary Level, and this is a question on coordinate geometry. So we're told the points A, which is 2, 1, and B, which is 6, 3, C, which is 5, 5, and D, which is 1, 3, are vertices of the rectangle ABCD. So that just means they're the corners of the rectangle. So they're the points that they've given us, and we are asked to show that AD is square root 5 units. So when I have AD and it's within these lines like that, that means the distance from A to D. So if I'm to get the distance from A to D, I'm going to have to use my distance formula, which is here on page 18 of our log tables. So x2 minus x1 squared plus y2 minus y1 squared. So I have to label A and D. So A I can call x1, y1, D is x2, y2. So we have x2, which is 1 minus, so x2, which is 1 minus x1, which is 2 squared, plus y2, which is 3 minus y1 squared. So that's going to be minus 1 squared, and then plus 2 squared. So that's going to give us 1 plus 4, which gives us the square root of 5. And that's what we were asked to show. We were asked to show that it was the square root of 5. And then in the next part of the question, we were asked to find in square units, so the area of the triangle ABCD. So the area of a triangle that we're used to getting is the length by the width. So we just need to get the length and the width. So we're already after getting the length from A to D. So that would be, say, the width of the rectangle. So we're going to have to get the distance from A to B now. So A is 2, 1, B is 6, 3. So we're going to have to use our same distance formula again. So it's x2 minus x1 squared plus y2 minus y1 squared. So we have to label one of our points x1, y1, and the other x2, y2. So x2, which is 6, minus x1, which is 2, plus y2, which is 3, minus y1 squared. So that's going to be 6a2, which is 4 squared plus 2 squared. So that's going to give us 16 plus 4, which gives us the square root of 20. But we can break the square root of 20 down. We can write that the square root of 20 as the square root of 4 multiplied by the square root of 5. And the square root of 4 is 2, so that would be 2 root 5. And another way we can get the square root of 20, if we plug it into our calculator, it does it out and it says 2 root 5 as well. So we figured out that this is root 5, and then the length is 2 root 5. So if the width is root 5 and the length is 2 root 5, well then the area is equal to the length by the width, which is equal to 2 root 5 multiplied by root 5. So when we multiply a square root by itself again, the square root actually cancels, so that's 2 multiplied by 5, which gives us 10 square units. Another way we can do that into our calculator, we can do 2 root 5 plus root 5 and we get 10. So that's how the calculator would have worked that out for us. And then in the next part of that question, so part B, we are asked to find the equation of the line BC. So, and they're asked to give your answer in the form AX plus BY plus C is equal to 0. So we know that the point B, so I'll just write down B is 6, 3 and C is 5, 5. So if I want to get the equation of a line, I need two things. I need a slope, the slope of the line, and I need a point on the line. So I have two options to get the equation of a line. The first one is y equals mx plus c. But if I'm to use this, I need to know the exact point where it crosses the y-axis. And in this case, I don't. So I'm not going to use that one. But I can use y minus y1 is equal to mx minus x1. I just need to know a slope, and I need to know the slope and a point. So if I'm to use y minus y1 is equal to mx minus x1. So if I'm to use this, I need to know m, which is a slope, and an x1, y1, which is a point. So firstly, I'm going to have to get the slope from B to C. So the slope always has to go from left to right. So if it's like this, it's going to be increasing. If it's like this, it's going to be decreasing. So my point B is 6, 3, and my point C is 5, 5. So the point that's closest to the left, I would usually take as my x1, y1, because it's going from left to right. So this is closest to the left because that has the lowest x value. And we can see that C is closer, so it's going to be a negative slope, and this is x2, y2. So our formula for our slope is x2 minus y2 minus y1 over x2 minus x1, and this formula is in our log tables here. So y2, which is 3, minus y1, which is 5, over x2, which is 6, minus x1, which is 5. So that's going to be minus 2, and this is going to be 1. So our slope is equal to minus 2. So now we have our slope, and we just need to use one of our points. So to use this, we need a slope and a point. So I'll write it down here. X minus x1. So our slope m is minus 2, and we can pick either one of our points as our x1, y1. So say if we go with B, so 6, 3, this will be our x1, y1. So if we're to plug that in, it'll be y minus 3 is equal to x minus x1, and then that's going to be y minus 3 is equal to minus 2x plus 12. So we're going to we're getting everything on the same side, and we might do with the positive x. So we can move everything to this side. So 2x plus y minus 3 and then minus 12 equals 0. So then if we're to tidy that up, it'll be 2x plus y and then minus 15 is equal to 0. So that is the equation of our line BC.